Okay, so at the end of the last video, I asked you to figure out whether cotangent, secant, and cosecant were even or odd. So the idea is we want to plug in the opposite of x and see whether we get out the same output or the opposite output as if we just plugged in x. And the trick is to rewrite it in terms of sines and cosines. So cotangent of negative x is just cosine of negative x over sine of negative x. Cosine is even, so that's cosine of x. Sine is odd, so that's negative sine of x. I get one negative sign, I can pull that out front, so that means I'm just getting negative cotangent of x. So that right there tells me opposite input, gave me the opposite output, cotangent is odd. Okay. Secant of negative x, that's the reciprocal of cosine of negative x. Cosine is even, so that's the same as a cosine of x on the bottom. So I get secant of x. Opposite input gave me the same output, secant is even. Cosecant of negative x is the reciprocal of sine of negative x. Sine is odd, so that's a negative sine x on the bottom. I can just bump that negative sign to the front, so I'm getting negative cosecant of x, and so that's odd. Okay. So basically, almost all the trig functions are odd. Sine of x and tangent of x and cosecant of x and cotangent of x are all odd. The only two that are even are cosine of x and its reciprocal secant of x. Okay. But kind of nice to know that they all have that property. So if I'm ever plugging in the opposite of some input, I can either, if it's cosine or secant, just drop the negative. If it's any of the other trig functions, I can pull that negative out. Kind of cool. Okay, so with that, we've reviewed all of the fundamental identities. I want to just practice using them a little bit. One of the things that's going to be really useful is to go from having 6 functions to just 2. If we can write everything in terms of sine and cosine. So what I'm going to do is I'm just going to put a couple of expressions up on the board. Let's say I have tan x plus secant squared x. And I just want you to write that using just sines and cosines. And then I'm going to have sine x minus cosine x times secant of x minus cosecant of x. With this one, I want you to do 2 things. I want you to write it just in terms of sines and cosines, but I also want you to multiply this out. And remember, that's going to involve foiling that. So we multiply our first terms, our outsides, our insides, and our lasts. So multiply this out, write both of them in terms of just sines and cosines. I'm going to suggest that you pause the video and do that, and then turn it back on and we'll check it out together. Welcome back. Okay, so if I wanted to write this in terms of sines and cosines, I'd say tangent is sine x over cosine x, plus secant squared is 1 over cosine squared x. Done. That's all I asked you to do, was write it in terms of sines and cosines. Now, if I wanted to, I could go one step further. I didn't specify that you needed to, so it's totally fine if you stopped here. But I could also say, hey, that's sine x over cosine x. If I wanted to be able to add these fractions, I'd need a common denominator. So if I multiply this one by 1 in the form of cosine x over cosine x, now I'm getting sine x cosine x on top, cosine squared x on bottom, plus 1 over cosine squared x. So that I can now write as one fraction with that common denominator of cosine squared x. And that's sine x cosine x plus 1 all over cosine squared x. These are both acceptable answers to that first question. Okay. All right, for this one, I asked you to do 2 things, multiply out and then write in terms of sines and cosines. Doesn't matter which you did first. I think I'm going to actually write it out in terms of sines and cosines first and then do the multiplication. So that's just remembering that secant is the reciprocal of cosine and cosecant is the reciprocal of sine. Okay. So When I FOIL, my first terms are going to be sine x times 1 over cosine x, which gives me sine x over cosine x. My outside terms are going to be minus sine x over sine x. That's kind of nice. I'm going to be able to simplify that to 1 in just a minute. My inside terms will be minus cosine x over cosine x. That's nice. I'll be able to simplify that to 1. And then my last terms are going to be minus cosine x over sine x. So we've got sine x over cosine x. It simplifies to just minus 1, and this simplifies to just minus 1, so it's minus 2 minus cosine x over sine x. Now, that follows the directions of just writing it in terms of sines and cosines. If that hadn't been the directions, I could say that's tan x minus 2 minus cotangent of x. And if I wanted to, I could get a common denominator here as well. That's a perfectly acceptable answer. I think I'm going to stop there. But that's just a little bit of what we can do with identities. And if you did combine these and get a common denominator, your answer is going to look a little different. That doesn't mean it's wrong. Okay? So, if you're working with things and it says, write this way, sometimes the directions are specific enough that there's one correct answer. Sometimes there's not. So if your answer doesn't exactly match the back of the book, but you think that you've done something right, ask me in office hours or shoot me an email or give me a phone call. Ask me, hey, I got this answer. This is the answer in the back of the book. Did I do something wrong, or do I just have an equivalent version? Because there are lots and lots of different ways that we can write things. That's the whole point of having the identities, that we have these options.